So in this lesson, we are going to look at finding what the area is between two curves, which is very similar to what we did in the previous lesson, but this one was just between a curve and the x-axis, versus now we're going to be looking at between two curves. So we have this green one here, so that's this curve here, and we want to figure out what the area is between that and then this linear function. Whereas before it was, here's our axis, let's find the area within our curve and my x-axis within a specific region, say from here to here. So now we have to take into consideration what our heights are going to be, because before our height was just the height here down to the x-axis. We change color. So from here to the x-axis, and we were summing up all of these. Whereas now we have to sum up from this point to this point. So in essence, what we're doing is we are subtracting the two y values for every single point. And what ends up happening when we do that is sometimes one function is on the top. So for instance, the green function is on the top. So I'm going to take this height of 5.28 and subtract the height of 3.33 because the pink one is below. But then when I get to this region here, now the pink is above and the green is below. So now I'm going to take the height of this point and subtract the height of this point to find my total height. And then I'm back to my green one on top and my pink one, and then my pink one on top, and then my green one. So what I have here is 4 different regions that I have to bring together that I'm going to have to sum up. Otherwise, I'm going to have some that are negative and some that are positive. And then I'd have to try to remember to flip all of those. So if instead I look at, okay, this is the one that's always above, then I don't have to worry about my negativities at all. So I'm going to quickly just refresh based off of this first example A from the previous lesson, just to remind you of how it worked with the x-axis. So when I'm finding this definite integral, it's going from -2 to 2 of this product, I'm going to have to figure out what my integration is. So step 1, expand, because I can't undo a product. So that gives me 2x cubed minus 6x squared dx. So now when I integrate this, I find that capital F of x. I'm going to ignore the fact that I have my bounds for right now, so I'm just going to integrate this function. So therefore, when I integrate this function, I get x to the 4th, which means that 2 is going to be divided by 4, minus, that's going to be x to cubed, which means the 6 is going to be divided by 3. And then we're going to have our constant term. And then this goes from -2 to 2. Okay, so this is what that integration looks like, just making sure that we have our notation correct. However, at this point now, when I plug in my 2 and -2, when I do that subtraction between the two, one's going to be a positive c, one's going to be another positive c, but I'm subtracting them so they go away. So we never have to worry about this plus c when we are integrating a finite integral. So I'm going to simplify this. I'm going to drop my c's out of there. So this is x to the 4th over 2 minus 2x cubed from -2 to 2. Okay, so now I'm going to go ahead and substitute in those numbers. So when I plug this in, I plug in my positive one first. So therefore we get 2 to the 4th, which is 16. So 16 over 2. And then that's minus 2 times 2 cubed, which is 8. And then we are going to take that and we are going to subtract, substituting in the -2. So -2 to the 4th is still positive 16 over 2. Minus 2 times, that's going to be -8 this time. So when I simplify this out, I get -32. And what ended up happening is what I was doing was I was finding my heights at these particular points in time in relationship to the x-axis, which is why I don't have to subtract anything, because that's going to be 0, and technically -0. So in this situation, I'm going to have to actually subtract those functions to figure out what my actual height is. And so that's the process that we're going to go through here. So we're going to integrate the difference of their heights, which is really just their functions, which we'll then look at substituting our numbers in eventually. So I'm going to have to subtract the two functions because those are my y values. This is the y of my green and then the y of my pink. So we'll look at an exact example with this. A lot of times you're going to want to sketch the functions or put them into your calculator. Depends upon what you have. But a lot of times if you have your calculator, then you probably would just use your calculator. So when I look at this, I'm going to go ahead and plot both of these graphs on here. So the first one, you can't really see my functions. There we go. My first one is a quadratic, down facing, shifting 4 units up, and then this is a linear. So again, this is one that you perfectly can do without a calculator. So go ahead and sketch both of those. So part of the reason I sketch these is I want to figure out where is my area because I need to know which function is above. So this is the area that I'm looking at, and I need to know where my barriers are. So where I'm going to integrate from, because they only are going to be integrating within those certain regions. So I want to figure out what's bounded by these two pieces. Because if I kept going this way, it would go to infinity, and if I went this way, my area would go to infinity as well. So therefore, I'm going to be bound between this x value right here where they intersected, which is at -2, and this x value where they intersected, which is 1. So I'm going to integrate from -2 to 1. And if it intersected a bunch of times, I'll do each of those individual pieces. So then, the one that's on the top is the red, so therefore I'm going to integrate 4 minus x squared, so that's the height of the red, minus the height of the green, which is x plus 2, with respect to x. So before I integrate any of this, we're going to simplify it. So -2 to 1, and then let's see, we have 4 minus x squared. Be careful with the subtraction, you're subtracting everything, so minus x minus 2, which is -2 to 1. Let's see, -x squared minus x plus 2. Whether you use square parentheses or regular parentheses is no big deal. So now at this point I have it simplified down, so now I'm going to go ahead and integrate this. So I drop my integral once I start to integrate. So negative, so this is x cubed, so that's divided by 3, minus, so that's going to be x squared, that'll be divided by 2, plus 2x to the first. Again, we ignore the constant term because we are looking at the area between curves. And then this again goes from -2 to 1. So I've already integrated. Now I can go ahead and plug those numbers in so I can find my actual area. Again, this is based off of what we did the previous day. So I'll put my highest number in 1. So that's -1/3 minus 1/2 plus 2. And then I'm going to go ahead and subtract. So that's -8, so that's +8/3 minus, so +4, so minus 4/2, minus 4. And then when I calculate both of those, so these are just all equals, and I'm going to just shortcut this, I get 9/2 units squared, or 4.5 units squared, either way you want to do it is fine. Now, in order to do this though, I had to figure out where my graph intersected each other. Now this one nicely I could easily see. If you can't see, you have to set the functions equal to each other. So in this case I could, it was really easy, the points were right on there. But otherwise, if I need to figure out where my x values are the same, I have to set my equations equal. So 4 minus x squared has to equal x plus 2. And then I'd solve that, and then when I solve that, I end up finding it's -2 and 1. So move this all over, so 0 equals x squared plus x, and then -2, so that I can factor that into x plus 2x minus 1, which means x equals -2 and +1, which is what we came up with here. So that's how you find those points of intersection if you don't know. And then if you're not sure which function is above, which function's below, pick a number in between these and see which one gives you the higher y value. So if I put in 0, so 0 is between these two. If I put 0 into my equation, I should get out 2 for this function, and I should get out 4 for this function. So that's how you can see which one's above then from there too. If it's not easy to graph, because sometimes they're not. Okay. Here we go. Okay, so this is going to be an odd looking function. So we're looking at the area bound by these two curves. So e to the 2x plus 1 and a nice linear. So this is an exponential function, shifted up 1 unit, and then this is a linear with a positive slope. So when I look at this graph really quickly, so positive slope is going to look like this some way or another. And then I have an exponential growth because e is positive, shifted up. So I know it's not going to go below my x-axis. So we have a region somewhere along the lines there. So again, that's just based on knowledge that you know. So I'm looking at this region here. Now the problem is I have no idea where these two functions intersect each other. Because of that, we're going to go right to our calculator and we are going to find that point of intersection. So go to your calculator, second calculate this value and this value. When you do that, so go ahead and pause this, make sure that you can do that. When you do that, you get this x value to be 0.6469. So I just went out a few decimal places just so I have it. And then this x value here is negative 2.9975. So those are the two x values that we have. So from this, I'm going to now integrate. I can see that my linear is on the top. So when I integrate, I'm going to integrate from my low value, negative 2.9975, to my high value, 0.6469. And then I'm going to subtract my two functions. So my linear goes on top, so that's x plus 4, minus the exponential, e to the 2x plus 1. Again, don't forget those parentheses because you are going to distribute through that subtraction sign. And then, oops, I lost my dx. Okay. So then we go ahead and we're going to simplify the inside. Negative 2.9975 to 0.6469. So when I simplify the inside, it doesn't simplify a whole lot, but I do end up getting x minus e to the 2x, and then 4 minus 1 is 3. So take a moment, go ahead and integrate this. So it's quite a bit of work when you're doing this by hand with these awful numbers. Now, I'm going to use my calculator because, let's be honest, we needed our calculator to find these points of intersection. Therefore, we would be expecting you to use your calculator. Now, because I asked you to integrate this because it's good practice, especially with e to a power of x, I'm going to go ahead and write the integration, but the above step I could already put in my calculator. Oh, I just wrote that. I'm sorry. I asked you to integrate it. Pardon me. Okay. So if I integrate that, I get x squared over 2 minus e to the 2x, integrating that, dividing by 2, plus 3x, technically plus c, but since I'm integrating, and then I'd plug this in, start with the top one, put this in for my x values, put this in for my x values, and subtract those two values. Or at this step right here, I go ahead into my calculator, and I can either do it under either spot. I can put it into my y equals. I could put this function into my y equals, and then this is my lower bound, this is my upper bound, and then with this I can calculate number 7, integration. Otherwise, it's also under math. For mine, it's under number 9, finite integral. So when I do that, I just have to plug in the x's. So that's another way to go ahead and calculate it. Okay, when I do either of those two methods, or if you did it by hand, you end up getting 4.83 as the area. So that is the area within this region. The last example is going to deal with multiple regions. So in this one, we have a cubic function and we have a square function. So when I look at these situations, I know I have some kind of cubic. I know I have a parabola that's perfectly fitting. So when I look at graphing this, so my parabola will look something like this. And then this is a cubic. If I factor out the x, that means it has to cross through my x-axis. So then I have, oh, that's not good. Let's try that again. This. So this is the parabola, and then this is my cubic. So I have these two regions in here. And again, if you are on an assessment with this and you didn't have your calculators, the numbers have to A, work out really, really nicely, and B, you'd have to be able to see exactly where they intersected. Okay, so like you may have to, this might be like an 18-point question if this was on a no calculator test, because the amount of time it's going to take you, you all should be able to graph a cubic, finding the zeros, and being able to plot those. So some of those different things, like you should be able to graph this by hand if it was like an 18-point question, and it's possible that it is. So then at that point, I need to figure out where do these functions intersect. So where does it cross here? Well, that's at 0, that's the easy one. Where does it intersect here, and where does it intersect here? So I have to set these two equations equal to each other. So when I do that, I get x squared equals x cubed minus 3x squared plus 3x. Set it equal to 0. So subtracting that, it's 4x squared plus 3x. Factoring out the x, and I'm left with x squared minus 4x plus 3. Factoring that, so product is 3, sum is negative 4, x minus 3, x minus 1. Again, this is all math you should be able to do for IB. Set each of these equal to 0, so x is 0, x is 3, and x is 1. So it intersects at 0, 1, and 3. So that's all the work I have to do to begin with before I can even set up my integration. So now, I'm going to go ahead and move this. I can set up my equation to solve. So in order to find my area, there's going to be two integrals. The first one is this first region here. So that's integrating from 0 to 1. The function that's on top is the cubic. So therefore, that is going to be x cubed minus 3x squared plus 3x. And we are going to subtract out the lower one, which is the parabola. And that is with respect to x. So that's the first integration. Then the second integration, I'm going to run out of space. Hold on one second. Then I'm going to add the area of the other region, integral from 1 to 3. So now I have to flip-flop which one's on the top. So now we have this part on the top, which is part of that parabola. So therefore, that's going to be x squared, and then I'm going to subtract out that cubic function, which is x cubed minus 3x squared plus 3x with respect to x. So the two separate integrations that I have to calculate to be able to find what my total area is. And again, all of this so far has been able to be done without a calculator. So when I do this, I'm just going to simplify my integral statements. So I'm going to subtract that x squared. So that's x cubed minus 4x squared plus 3x dx plus integral from 1 to 3. So I'm going to get a negative x cubed and then 1 minus 3, 1 minus a negative 3, so that's plus 4x squared minus 3x with respect to x. Just checking my negativities here. That one's good. And that one's good. Okay, so now we're going to go ahead and integrate. So I'm going to drop my integral symbol and I bring out these square brackets. So x to the 4th over 4. Go ahead and do that without my help. So then minus 4x cubed over 3 plus 3x squared over 2 from 0 to 1 plus negative x to the 4th over 4 plus 4x cubed over 3 minus 3x squared over 2 from 1 to 3. Now I go ahead and plug in those numbers. So this one's nice because it's 0, because this one is with, in essence, that x-axis piece. So therefore, when I put that 1 in, I just get a 4th minus 4/3 plus 3/2. Technically, minus 0. Because when I put 0 in, I get 0 minus 0 plus 0. Now, if there was like a constant term or something like that, then it would be different, but there isn't. And so then I add, and then I plug in the 3. So when I plug in the 3, let's see here, I get negative 81/4 plus 3 cubed is 27 times 4, so that's 108 over 3. Minus, so 3 squared is 9 times 3, so 27 over 2. And then I'm going to subtract, putting in the 1, so that's negative 1/4 plus 4/3 minus 3/2. And if I did all my fancy fraction work, again, you can do that all without a calculator. This becomes 5/12 plus this whole piece right here. So the first fractions in parentheses, that's 9/4. And the second, if I did my math right, is negative 5/12. And combining all those together with common denominators and so forth, we get 37/12, which is 3.08 square units. Okay, so a little bit messier. Okay, so maybe the fractions were a little bit hard to do without a calculator on an IB exam, but it's not without reason. It's stuff that you absolutely can do. So take a look at those. Realistically, if you're going to get these kind of fractions, most likely you're going to have a calculator, so you'd be able to kind of check some of this work along the way. But just be careful that you don't jump to your calculator too quickly when you're doing your homework, because you may end up needing to be able to do it without your calculator too, so not just using that integration. Okay, so for homework is 10J 1 through 9 odds, and then 10K numbers 1 through 5.